Any other questions up to this point? No. Okay. So we've calculated our propensity score having run this logistic regression model with those 30 variables and then calculated for each individual patient what was their propensity score. We then assume that within a level of the propensity score, whether a patient received the drug or not was purely at random. So for everybody with a score of 0.8, we assume that everything else about them is equal. Yeah? Some of them got the treatment, some of them did not get the treatment. But if I could just compare everybody with a score of 0.8, I should get an answer that's free from confounding, because those two groups of people, treated and untreated, with a score of 0.8 should be very similar to each other. Yeah? It relies on the fact that doctors' prescribing habits are a bit messy and a bit haphazard. It doesn't mean that they're totally awful. It doesn't mean that when I go see my doctor, he just spins a wheel and gives me whatever drug the wheel lands on. But it means that there's a little bit of variation in how prescribing happens. And those, I think, who here is a prescribing doctor? So would you agree that there is maybe a little bit of variation in how prescribing happens? A little bit, okay. This is no criticism of how clinical medicine works. It's purely I think it's just a fact that there are some patients who maybe don't want to take treatments, other patients more so. There's variation, okay. Yeah, please don't hear that as criticism. It means that for us as investigators, we can make use of this variation. And what we could do is potentially one of three major things that we can do. We could either match patients who've got very similar scores to each other. So for every statin user, I could match them all with a non-statin user with a very similar score. What happens if I can do that? It means that my baseline table of the exposed and the unexposed will look very, very similar. So the age, the sex, the distribution of heart disease, diabetes is going to look very, very similar between the exposed and the unexposed. It means I could then run a very simple Cox model or Poisson regression where I don't need to adjust for anything because I've got these two populations where their distribution of risk factors is the same. Known risk factors is very important to say. So that's one thing I could do. I could stratify, so I could look separately at people with a score of 0.8, 0.6, whatever, and just do my comparisons within strata and then combine them. Or I could just adjust for the score itself in a statistical model. It turns out that if I adjust for the score, rather than those 30 individual variables that contribute to the score, it actually does a very similar job in terms of the adjusting for confounding. What's really important to remember is if I match and my baseline table 1 shows them being very similar to each other, we have to remember that it's not the same as randomization and that patients could still be very different from each other on factors that we didn't include in the propensity score and that we don't know about. Okay? So a bit more about the theory. When we have calculated the score for our exposed and unexposed, we can then look at the distribution of the scores in those two groups. And this is really informative. So here we've got, I've taken this from a really nice paper written by Till Sturmer in 2006, which is a great kind of simple approach to propensity scores. If you want to get a paper to look at about, I would recommend this one. And here on the Y, on this axis we've got the number of subjects, and on the x-axis we've got the propensity score, so ranging from 0. So a score of 0 would mean very, very unlikely to be prescribed the drug, up to 1, which means extremely likely to be given the drug. Yeah? So here the broken line shows you the distribution of scores for an unexposed group. So it's tending to be towards the 0. And for here we've got the distribution for the exposed patients, and it tends to be closer to 1. But what you can see is that there are no exposed subjects in this group here. So at the lower end of the score, everybody is untreated. Yeah? This, if you like, is a way of finding our yoga retreat women. So the first cartoon I showed you with a woman who was going on a yoga retreat, I think the people who are a bit like her are all in this group here. This low distribution of the propensity score. Conversely, I think over here we've got this high score and everybody's exposed. There are no unexposed people with a score at this extreme end. This is all of our overweight, junk food eating guys who sit around all day and they're all taking statins, as a cartoon example. So when I said at the start of the session, it's very difficult to identify these unusual groups of patients. Well, this is one way that you can potentially find them, is by doing this propensity score and then comparing the distribution of exposures. Okay? The argument then is that if we want to do a fair comparison between exposed and unexposed, then maybe we ought to only look at people who have a propensity score that's within this distribution where both exposed and unexposed people exist. Yeah? So maybe we ought not to include these people and these people in our analysis. Okay? Now in reality, the distribution rarely looks quite as nice as this. It may look a bit more like, even this is quite nice, it may look a bit more like this, where you've got a full range of scores in both the exposed and the unexposed, but you've got a definite tail off amongst the exposed at the lower end and amongst the unexposed at the higher end. Okay? This is probably more like the reality. There's another argument that says, if we want to make a fair comparison, maybe we ought not to include the people at the very extremes of the score and who were treated contrary or other than you would have expected from their score. So here you've got people with very, very low scores but who are given the treatment. Conversely, you've got people with very, very high scores who are not given the treatment. And the question is, are these really weird people? And if they're really weird, how are they weird? And do we want to include them in the analysis? So there's a question that we may want to exclude them. There may be something that we don't know about those people, but which is really important for our research question and that we can't account for in the analysis.